Okay, we are back. Um, let's try out if the milestone achievement is that in fact we can actually compile the Haskell code that got generated, right? So let's do the make command again, so everything gets generated for us, and then we can pop into the Cabal shell and inspect the modules that have been generated. Okay, that means the modules have successfully compiled. Let's see what the modules, which modules do we even have? Okay, the Lambda buffers. Okay, obviously we have the citizen module, that's the one we wanted to compile, but also we have all the necessary dependencies being compiled and generated for it. That means Plutus, Plutus V1, V1, Prelude, and the runtime module that contains some, well, runtime necessities for operating Lambda buffers. It's quite minimal at the moment. So let's import the Lambda buffers citizen module, and let's see what Lambda buffers citizen module has. So obviously it has the citizen type. It has all the types listed on the left hand side of the screen. The citizen creation OIB. We have the name type, the national ID, uh, basically everything that's listed here. So let's try and create an example citizen, two example citizen. We're gonna try to compare them for equality, and then we will try to encode them into Plutus data such that we can store them on the Cardano network. We're not going to be storing anything on the Cardano network, but just as a proof of concept. So how do we make a citizen? So we generate standardly in a standard fashion. We generate a mc citizen a constructor function. It's not visible in the schema, but that's how we decided to do it. So the first thing that we need to do is assign a first name, the last name, and then the national ID. I know that I will need to work with Plutus bytes, so I'm just gonna go ahead and import that, so I don't have to do it afterwards. So this is in Plutus Ledger API with V1 bytes. Okay, what I will need is the from bytes function. I love this doesn't work. Yes, yes, that takes Haskell native base string, native base byte string, and takes it into a Plutus byte string. Okay, so let's make a citizen called Rajan, which is me. Make citizen. Okay. What next? I want to make a name. Okay, what name? It's gonna be my name, Dražen, right? But for that I need to say from bytes. And this is gonna uh, behind the scenes perform UTF-8 encoding on this Unicode string Dražen. The second name is the last name is Popovic. So let's go ahead and put that in. And then the national ID, it's funny why I started thinking about citizenship, because I just had my passport expire, so I don't have any national document by me that's valid. So I'm gonna just use the Swiss visa that I still have that's valid. So we want to have a national ID. So let's see how we can create a national ID. Let's see, a national ID. Okay, obviously we can make a creation ID card, passport, or Swiss visa. Let's do a Swiss visa. And now we need to make a Swiss visa. So how do we make a Swiss visa? We know it's a sum type. So we have a B, C, and L types. I only have a B currently. So let's see, this should now work. Bam, it did work. So now we created uh, a citizen within Haskell, and we specified the same citizen within the Lambda buffer schema. well, not the same citizen, but the type of citizen in the Lambda buffer schema. Let's do another one. Let's do my brother. Why not? It's gonna be the easiest because we have the most in common. Okay, his name is Nenad and he has a Croatian ID card, and then he only has the Croatian ID card is here and it's only a number, so make Croatian identification number, and his identification number is 1337, which is not true, but let's go. Okay, now we have two values, Nenad and Dražen. They are of type citizen. Okay, let's compare them for equality. Is Dražen equals to Nenad? I'm sorry, I forgot to input valid. Is Dražen, why don't I do this? Is Dražen equals to Nenad? That's false. Is Dražen equals to Dražen? That's true. And is Nenad equals to Nenad? That's true. Okay, let's see what happens when we we try and encode these two values as Plutus data. Let's first import the type class methods for Plutus data, which is in Plutus dx, and say Plutus to data Dražen and see what happens. Okay, we got the encoding, which is great, and it just says that it's a tuple of 3 elements. And to data Nenad, same thing. Okay, this seems to be working fine, so I'll go ahead and move on to the pure script side of things, and we'll kind of redo the same story just with pure script.